All right, welcome to the deep dive. Today, we're going to be tackling Squid Proxy Server 3.1.
Okay.
Specifically, we're going to be drawing from this material, Squid Proxy Server 3.1 Beginner's Guide by Kulbir Saini,
Right.
published back in February 2011. Our goal here is to kind of get the core of how Squid can be used to really boost network performance using caching and access control. So think of this as getting the core knowledge without having to wade through all the details of the full manual, right?
Yeah. I think it's really exciting because we can kind of break this down and see how Squid can make your network traffic flow faster
Mhm.
and really help manage who can access what. And I think the idea here is that it's not just about understanding a piece of software. It's really about grasping the fundamental concepts of how the internet works and how to optimize its delivery.
Right, right. So whether you're, prepping for some tech discussion or just trying to understand why some websites load faster than others, or maybe just curious about the nuts and bolts of how the internet works, knowing what Squid does and how it does, it gives you a valuable perspective on managing network traffic and security. So we're going to focus on the essential takeaways here
Great.
and why they matter. Okay, so let's unpack this. At a fundamental level, what is a proxy server when we talk about web caching?
Yeah, that's a great place to start. At its core, a proxy server acts as a go-between.
Hmm.
So picture it as kind of a smart traffic controller sitting between your computer, the client, and the website or server you want to reach, which we call a target server.
Yeah.
Every request you send and every response you get travels through this proxy. And what the proxy can do then is check these interactions against a set of rules.
So it's almost like a border agent for internet requests, making sure everything looks legit before letting it through, right?
Yeah, that's a very helpful way to visualize it. And one particularly interesting feature that Sarita highlights is reverse proxying.
Yeah.
So now instead of being that intermediary between many clients and many websites, a reverse proxy sits in front of one or more web servers.
Oh, okay.
So what's fascinating here is that it stores copies of the web server's responses.
Yeah.
So when someone requests a page, the reverse proxy can often serve it directly from its own local storage without even needing to contact the original web server.
Okay.
So you can see beyond just speed, right? Reverse proxies have become a critical point for security, load balancing across multiple servers, and even enabling advanced content delivery network strategies. Think of it less as just a mirror and more as a strategic control point in your web infrastructure.
Uh-huh. So it's not just about speeding things up for the end user. It's about protecting and making the actual website infrastructure more efficient too.
Right.
And that connects directly to the general idea of web caching, doesn't it?
Absolutely. Web caching is the basic process of storing frequently accessed web content, things like web pages, images, and videos, in a location closer to the user.
Yeah.
And Squid does this using both its RAM for quick retrieval and its hard disks for longer-term storage.
Okay.
And what this does is dramatically reduces the amount of bandwidth needed because the proxy can serve up the cached content instead of constantly re-downloading it from the original source. And this also leads to a much snappier experience for anyone trying to access that content.
Okay, so we've got the what and the why of proxy servers and caching. Now, the guide gets into installing and compiling Squid. I'm used to just downloading and running installers, so why would someone go through the extra step of compiling from the source code? Sounds a bit technical.
Yeah, you're right. For a standard installation, pre-compiled versions are definitely easier. But Sindy makes a really good case for compiling from source. If you need more control. What's fascinating here is the level of customization that you can achieve. When you compile it yourself, you can specifically choose which features to include or exclude. Things like different ways to handle authentication or support for specific networking protocols. So it really lets you tailor Squid to fit your exact needs.
So it's about having that fine-grained control over exactly what features are baked in.
Exactly. Plus, when you compile the configure script, can actually examine your specific computer system and optimize the software build for it. Precompiled versions are made to work on a wide range of systems, so they can't be as finely tuned.
Right.
And another benefit is that you can choose to install Squid in a specific location on your system without needing special administrator privileges, which can give you more flexibility in certain environments.
Okay, so if you wanted to, test out a specific version or configuration in an isolated environment, you could do that.
Yes, absolutely. And Siny even provides a basic example of the configure command, which is .configure prefix opsquid 3.1.10.
Okay.
And this prefix part is what tells the system to install Squid in that specific directory.
Okay. Okay, so he mentions a few other interesting configure options, disable optimizations for debugging, which makes sense. You want to see the raw behavior.
Exactly.
And then enable Storio for different disk input-output methods. That sounds like something for really tweaking performance depending on your storage hardware.
Precisely. The enable Storio option allows you to select different modules for how Squid reads and writes data to the disk.
Okay.
And the best choice can really depend on your specific storage setup and how busy your proxy server is. He also mentions enable cache Mara hostname for setting the hostname of the cache manager web interface, and enable ARPL, though he notes this has been replaced by enable UE and is on by default now,
Okay.
which lets you create access control lists based on the physical MAS addresses of network devices.
Yeah.
So think of a MAS address like the unique physical address of your computer's network card, like its serial number. And filtering by MAS address is a very low-level way of controlling network access right down to the specific hardware.
MS address filtering, that's getting right down to the metal. Then a couple of disable HTCP if you're not using the hypertext caching protocol with other caches. And then the with logdir and with pin file options to put the log files and the process ID file in specific locations.
Right.
And finally, with auth threads for controlling how Squid handles multiple requests with the auth storage system. It sounds like the configure step is really about setting the stage for exactly how you want Squid to be built.
Right.
And where it fits into your system.
Exactly. It's about having very granular control from the beginning.
Yeah.
Now, once Squid is installed, the real engine room of its operation is the squid.config configuration file.
Ah, yes. The famous config file.
Yeah.
Saini talks about the general way it's structured. Is it just a big list of settings?
Pretty much. It's a plain text file where you list directives and their corresponding values.
Okay.
And then he dives into some of the most important directives, starting with HTTP port.
Okay.
And this one is critical because it tells Squid which network address and port number it should listen on for incoming requests from clients.
Okay.
The default is usually port 3128.
And he mentions some interesting extra options you can add to HTTP port, like intercept and tproxy.
Yes. Intercept is what enables intercept mode.
Okay.
And that's where network traffic is transparently redirected to Squid, often without the client application even being aware that a proxy is involved.
Yeah.
Proxy is similar, but it's specific to Linux, and it allows for truly transparent proxying, where the proxy can even appear to be the original destination server to the client. It is important to note, however, that using either intercept or tproxy will disable any user authentication you might have set up.
Right. That makes sense. If the traffic is being secretly routed, Squid can't really pop up a login box, right?
Yeah.
And he also mentions Excel mode.
Right. That's short for accelerator mode, which is used when you're setting up Squid as a reverse proxy.
Okay.
The kind that sits in front of your web server.
Yeah.
And Sunny points out that when using Excel, it's typical to have Squid listen on port 80, which is the standard port for HTTP traffic.
Okay.
However, just enabling Excel isn't enough. You also need to tell Squid which website or websites it's supposed to be accelerating.
Okay.
And we'll dig deeper into reverse proxying a bit later.
Okay, so HTTP port is how clients get to Squid. What about HTTP preply access? Saini has a pretty serious warning about that one.
He does. And it's a really important security point.
Mm-hmm.
HTTP preply access is used to control whether Squid actually delivers the response that it received from a web server back to the client.
Mm-hmm.
And the risk comes in situations where a potentially harmful request, like one using the HTTP-OST method to send sensitive data, is allowed to reach the destination server by your other rules. HTTP access. If HTTP preply access then blocks the response from being sent back to the client, the client might think nothing happened.
Right.
While in reality, the data could have been successfully transmitted to the bad actor.
Yeah.
So you need to be very careful when you set up rules with HTTP preply access to avoid accidentally creating security holes.
Yikes. That sounds like a subtle but critical security risk to watch out for.
Yes.
Okay. Another key directive he talks about is cache peer.
Yes.
And that's how you set up those hierarchical caching relationships with other proxy servers,
That's
right?
right. Exactly. Cache peer is how you tell your Squid server about other Squid servers it can communicate with.
Mm-hmm.
Either parent proxies, which are upstream servers that your Squid can forward requests to if it doesn't have the content, or sibling proxies, which are peer servers that might also have the content cached.
Gotcha.
Sakini highlights the proxy-only option, which, when used with cache peer, tells your Squid server not to store the content it retrieves from that specific peer in its own cache.
Oh, okay.
This might be useful if you're connecting to a very large, well-maintained upstream cache where you trust its contents to be fresh,
Mm.
and you don't want to duplicate them locally. It's like borrowing the answer from the smart kid, but not writing it down yourself.
Interesting.
Yeah.
And he also briefly mentions cache peer domain as a quick way to say that certain website domains should only be accessed through specific peer proxies.
Yes. Cache peer domain gives you a simple way to define that traffic to particular domains should be routed through a designated cache peer.
Gotcha.
It's a shortcut for implementing basic routing based on the website being requested.
Oh,
Now, let's really dive into the core of what makes Squid useful,
okay.
the caching itself.
All right, let's talk about where the magic happens. Saini explains that Squid uses both RAM and the hard disk to store cached content.
Right.
How do you decide how much of each to use?
Yeah. So you use the cache directive to set the amount of RAM you want Squid to use for caching.
Okay.
And back in Squid 3.1, the default was 256 megabytes.
Mm-hmm.
Saini wisely advises against allocating too much RAM to Squid, as that can cause your operating system to start swapping memory to disk,
Right.
which actually slows things down overall.
Okay.
On the other hand, if you allocate too little RAM, Squid might not be able to effectively cache frequently accessed small objects,
Okay.
limiting its performance benefits. It's a bit of a balancing act.
Yeah, so it's like finding the sweet spot for memory usage.
Yeah.
What about using the hard disk for caching? That's
Yeah.
where the cache directive comes in.
Okay, the cache directive is used to define the directories on your hard drive where Squid will store the cache web files. And Saini breaks down the syntax like this. Cached to your storage type directory. Size and bytes L1, L2 options.
Okay.
The storage type specifies the type of file system you're using for that partition.
Okay.
Common ones in Linux Unix are X2, XT3, XT4, etc.
Yeah.
The directory is simply the path to the cache directory you want to use.
Uh-huh.
Size in MB sets the maximum amount of disk space in megabytes that this cache directory can use.
Okay.
And L1 and L2 define the number of first and second level subdirectories that Squid will create within the main cache directory to organize the cache files efficiently.
Okay.
This helps Squid quickly locate and manage the potentially large number of cached objects.
So it's like creating a mini file system inside your regular file system, specifically designed for storing web content in an organized way.
Exactly.
And as the cache fills up over time, Squid needs a strategy to decide which older items to remove to make room for new ones. Saini mentions that the most common approach is to remove the objects that haven't been used for the longest time, that's least recently used,
Right.
or those that aren't accessed very often, that's least frequently used. So it's like cleaning out your closet, right? The stuff you haven't worn in ages gets donated.
Yeah, exactly.
Now, how does Squid know when a piece of cached content is still fresh? It can't just keep serving up old versions of websites, can it?
No, it can't. And that's where controlling object freshness comes in.
Mm-hmm.
Squid primarily looks at the HTTP headers sent by the web server, along with the content,
Okay.
specifically the expires, last modified, and date headers.
Okay.
If the expires header indicates a date and time in the past, the object is considered stale. If there's no expires header, Squid can use a combination of the last modified header, which is when the content was last changed, and the date header, which is when the server sent the response,
Uh-huh.
to try and estimate how the content should be considered fresh.
So the web server is supposed to give Squid and web browsers, I guess, hints about how long to keep something around. But what if the web server doesn't provide that information? Or what if you want to override those hints?
Yeah, that's where the refresh pattern directive comes into play.
Okay.
It allows you to define your own rules for how long Squid should consider an object fresh based on regular expressions that match the URLs of the content.
Uh-huh.
The basic syntax is refresh pattern rejects min percent max,
Okay.
where min percent and max are all-time values in minutes.
Okay.
The min parameter sets a minimum time that an object will be considered fresh, regardless of what the server's headers say. The percent parameter allows you to define freshness based on a percentage of the time difference between the last modified and date headers.
Mm-hmm.
And max sets an absolute maximum time that an object can be considered fresh.
Okay.
So this gives you a lot of control over how aggressively Squid caches different types of content.
He also lists some fascinating options you can use with refresh pattern, like override expire and override last mod. Those sound like they let you really take charge of the caching behavior.
They do indeed.
Mm.
Override expire tells Squid to completely ignore the expires header sent by the web server.
Okay.
And override last mod tells it to ignore the last modified header.
Gotcha.
There's also options like ignore reload to prevent browsers from forcing a fresh download.
Okay.
Ignore no cache and ignore no stored to tell Squid to disregard those directives from the server.
Okay.
And reload into IMS, which is a clever one.
Yeah.
It turns a browser's reload request into a conditional if modified since request, which can save bandwidth if the content hasn't actually changed.
Oh, okay.
Yeah.
That's some seriously fine-tuned control over caching. He also mentions dealing with partial downloads.
Right.
Why would you need to worry about that?
If a user starts downloading a large file through the proxy and then cancels the download before it's finished, Squid might continue downloading the rest of the file in the background.
Oh, right.
Which wastes bandwidth and server resources.
Mm-hmm.
The quick abort min, quick abort max, and quick abort prit directives help manage this.
Okay.
They let you set thresholds based on the amount of data downloaded and the percentage of the download completed.
Okay.
And if the client disconnects before these thresholds are met, Squid can be configured to stop downloading the rest of the file.
Okay.
It's about not wasting resources on downloads that are no longer wanted.
Makes perfect sense. No need to keep fetching something nobody is going to use, right?
Exactly.
He also has a warning about caching failed requests using the negative vettel directive.
Right.
What's the potential problem there?
Yeah, so the negative vettel directive allows you to cache the fact that a requested resource was not found, like a 404 error.
Okay.
Or that access was denied, like a 403 error.
Uh-huh.
And the issue, as Scene points out, is that this can go against the standard way the internet is supposed to work.
Okay.
Because these error responses aren't generally meant to be cached for long periods.
Right.
If you cache them for too long, users might keep getting error pages even after the problem on the remote server has been fixed. So imagine a website being temporarily down for maintenance.
Yeah.
If you aggressively cache that 404 not found response using a long negative vettel,
Right.
your users will keep getting the error even after the site is back up, leading to a lot of frustration.
Right.
So it's a feature to use cautiously.
So it's about avoiding getting stuck in a negative feedback loop of cached errors, right?
Right.
He finishes up the caching section by discussing how you can control the HTTP headers in both requests and responses using request header access and reply header access.
Yes. And these directives, when used with access control lists, which we'll get to in a moment, give you the power to selectively allow or deny specific HTTP headers from being sent or received.
Okay.
For example, you could remove the user agent header to reduce the information web servers get about your client's browsers.
Okay.
Or you could remove the refer header to prevent websites from knowing where your users came from.
Okay.
However, Saini rightly warns that removing certain headers can actually break some websites or applications that rely on this information. And by default, Squid doesn't modify any headers.
Okay, so we've covered the core of caching. Now let's move on to setting up DNS and logging. Those seem like pretty fundamental things you'd need to configure correctly.
Absolutely. Proper DNS configuration is essential for Squid to efficiently translate website names into IP addresses.
Okay.
The DN server directive lets you specify the IP addresses of the DNS servers you want Squid to use. You can also use DNS program to specify an external program for resolving DNS queries. And you can control how many of these programs Squid runs simultaneously using DN children.
Okay.
The DNS timeout directive lets you set how long Squid will wait for a response from a DNS server before giving up and trying another one.
And just like with web content, there's also DNS caching involved, right?
Yes, Squid caches both successful DNS resolutions, those are
Yeah.
positive responses,
Okay.
and unsuccessful ones, those are negative responses, like when a domain name doesn't exist.
Uh-huh.
The positive anostettal directive controls how long the successful resolutions are kept in the cache,
Okay.
and negative anostettal controls how long the failure responses are cached.
Okay.
Saini recommends keeping the negative TTL uh, relatively short
Yeah.
because domain name issues can often be temporary.
Right.
You don't want to keep thinking a website doesn't exist if it was just a momentary DNS problem.
Makes sense. Now, on to logging. What are the key things you need to set up there?
Okay. The main directive for logging is access log.
Okay.
This allows you to specify the file where Squid will record all the client requests and the server responses that pass through it.
Uh-huh.
You can also define the format of these log entries to control exactly what information is included. Squid comes with several predefined log formats like Squid and Common, and you can even create your own custom formats using various format codes,
Okay.
such as %client tip for the client's IP address,
Yeah.
% method for the HTTP request method like GET or POACE,
Okay.
%URL for the requested website address,
Okay.
and %HTTP status for the HTTP status code like 200 for success or 404 for not found.
Okay.
You can really tailor the logs to show exactly the information you need for monitoring and troubleshooting.
So you can really get down into the details of what's being logged. What about managing those log files over time? They could get pretty large.
Yeah, that's where the log file or rotate directive comes in.
Oh.
It lets you tell Squid how many old versions of your log file it should keep before it starts overwriting the oldest one.
Okay.
The default is often around 10 rotated logs.
Gotcha.
If you want to be more selective about what gets logged,
Uh-huh.
you can use the log access directive in combination with access control lists or ACLs.
Okay.
For example, you might want to avoid logging requests from certain internal IP addresses.
Okay.
Saini also mentions that you can enable separate logging specifically for the referrer and user agent HTTP headers if you're interested in tracking that information.
Okay.
And interestingly, you can even configure Squid to output its access logs in a format that looks like a standard web server's log file
Uh-huh.
using the common format,
Okay.
which can be useful if you're using existing weblog analysis tools.
Okay, logging seems pretty flexible. Now, let's talk about access control lists, or ACLs. Sanine says they are absolutely fundamental to how Squid works.
They are indeed. ACLs are the core building blocks for identifying and categorizing different kinds of web traffic based on a wide range of characteristics.
Okay.
And the basic structure is ACL name type criteria.
All right.
The name is just a label you give to your ACL so you can refer to it later.
Right.
The type specifies what kind of characteristic you're trying to match, and the criteria is the actual value or pattern you're looking for.
Okay. And he lists a whole bunch of common ACL types like SRC for the source IP address, making the request,
Right.
DS state for the destination IP address of the server being requested, circ domain and gist domain for matching based on domain names,
Right.
and then more flexible regular expression versions like circ dom regex and c domain.
Exactly. You also have time for matching based on specific times of day or days of the week.
Okay.
URL regex and URL path regex for matching specific patterns in the requested URLs. Proxy auth for matching based on whether a user has authenticated with the proxy or based on specific usernames.
Okay.
Recheater and repeater for matching against specific HTTP headers in the requests and responses. HTTP status for matching based on the HTTP status code returned by the server.
Okay.
And even port and proto for matching based on the destination port number or the network protocol being used.
Okay.
So it's a very comprehensive set of tools for identifying different types of traffic.
Wow, that's a lot of different ways to slice and dice network traffic. He also mentions the range feature for IP addresses, which sounds really useful for specifying a whole block of IP addresses without having to list them all out individually.
Yeah, the range feature lets you define a continuous range of IP addresses,
Okay.
which makes your ACLs much cleaner and easier to manage when you're dealing with larger networks.
Yeah.
It's also generally more efficient for Squid to process than having a long list of individual IP addresses.
Okay.
Citing also makes a note that while you can use DSD ACLs to match based on destination IP address, they can sometimes be slower than SRC ACLs.
Oh, okay.
Because Squid might need to do a DNS lookup
Hmm.
to get the IP address of the domain name before it can perform the match.
Right.
So if you could achieve the same result by matching on the source IP address,
Mm-hmm.
that's often the more performant approach.
Good to know. Stick with source-based matching when you can for better performance. So once you've defined all these ACLs to identify the traffic, how do you actually do anything with them?
Right.
That's where the access list rules like HTTP passes come in, right?
Precisely. Access list rules are what determine whether access is allowed or denied
Yeah.
based on whether a request matches the ACLs you've defined.
Mm-hmm.
The most common one is HTTP passes,
Okay.
which controls access to the HTTP protocol.
Right.
The basic syntax is HTTP passes allowing.
Right.
And Squid evaluates these rules in the order they appear in the squid.conf file from top to bottom.
Okay.
The first rule that matches the current request is the one that's applied.
Okay.
And if you have multiple ACL names listed in a single rule, all of those ACLs must match for the rule to be considered a match.
So it's like a series of security checkpoints. If your request meets all the conditions of an allow rule, you get through.
Right.
If you hit a deny rule where all the conditions match, you're blocked. And that exclamation mark in front of an ACL name, that's for saying not this ACL.